In this lesson, we're going to look at samples and surveys. This unit has much vocabulary associated with it. So let's start big picture. First of all, a population consists of all the items or subjects of interest. And when we talk about the numerical attributes of the population, they're known as parameters, all right? So P and P. So if I'm talking about the mean of a population, it's called a parameter, and it gets its own letter. It gets mu. This chart down here shows you the letter that we use. We use X bar or Y bar when it's a statistic from a sample, and we use mu when it's from a parameter. Often, it's too difficult to look at an entire population. For instance, maybe I want to know the average length of great white sharks. Well, getting every single great white shark from the ocean is not realistic. So what do? I look at a sample of great white sharks. And this is the group of individuals selected from the population. The data we collect will be known as statistics. All right, so look at the chart below to see the different letters we use to represent statistics. So X bar and mu we've talked about when we looked at the normal curve. Standard deviation, we use S when it's a statistic. We're going to use sigma for a parameter. Correlation, we use R or rho. Our regression coefficient will be B or beta. And then for proportions or like percentages of something, we use P hat when it's a sample statistic and P when it's talking about the parameter. Collecting data from an entire population is known as a census. Just like in the United States, the Constitution mandates that every 10 years we must do a census to collect data on our citizens. Now, as I was saying, one of the big ideas is it's often too challenging to collect data from an entire population. Just not feasible. So what do? We do different sampling methods to collect a sample. And we're hoping that this sample is a good sample, that it looks like our population, that it's representative of it. If it is, we get to make an inference back to the population, meaning, for instance, if I collect with those great white sharks, I collect a good sample, and we'll talk about what it means to be good. Part of this is it needs to be randomly selected or otherwise in some way representative of the population. If it's a good representation, a good sample, then I can make generalizations back to the entire population. If it's a bad sample, the best I can do is just talk about that sample. So let's talk about our different methods of, I'd say, good sampling. So the SRS, or the simple random sample, this is our exemplar, meaning it's what many of them strive to be. Here are some conditions on a simple random sample. It is where every individual has an equal chance of being selected, but that's only part of the definition because there are other sampling methods that fits as well. The part that you're always tested about is, and every group of a given size has an equal chance of being selected as well. So let's say you have 500 people and you want to do a simple random sample, an SRS. So here's what you do. You label them like 1 through 500, and then you use a random number generator to generate, let's say you want 50 numbers. Okay. It would be necessary to also say that you're ignoring any repeats and irrelevant numbers if you were using like 0 through 999 for a random number table. But here's what is not an SRS. So let's say of these 500 people, there are 300 men that make up the group and there are 200 women. So you decide that you want an equal amount of, or a proportional amount of men and proportional amount of women. So you decide, you know what, I'm going to pull a sample of 30 men and a sample of 20 women. Okay? So each person 30 out of 300, if you're selecting, would be 10%. 20 out of 200, 10% of women would get chosen, 30% or 10% of men would get chosen. This is not an SRS though, because every group of people that you could possibly create do not have an equal chance of being selected. Easiest way of saying this, it's impossible if I choose to do it this second way of getting a group of all 50 men. Maybe I don't really want that to happen, but that's not an SRS because it doesn't have the chance of happening, right? So every possible group of size N must have that equal chance of being selected. And I just want to zoom in here and show you this great graphic that Miss Todd shared with me. And what she has done is she's showing you with a picture what an SRS is. So here is our population. You number them 1 through 8. You use a random number generator to generate your sample. And her graphic illustrates that all samples of size N are equally likely to be selected. All right, let's talk about our next sampling method, which is a stratified, and sometimes you'll see that called a stratified random sample. Don't call this an SRS, uses the same letters, okay? Not at all the same. Stratified random sample. And what do you do with this? Okay, so what you do first is you divide the population into homogeneous groups, which we call strata, based on some sort of shared attribute. Then we randomly select individuals from each stratum, that's your singular, so all strata are represented. One of the benefits of stratifying is that it can reduce your variability. We saw that in our dot plots, which is this variability is also known as your sampling error. One of the things I always kind of say, try to give you guys some memory tricks, stratified S&S, it's same within and different between. So the strata you build, they're all alike in some way. Like in the previous example where I said it was not an SRS, if we first split it into men and women, then our strata would be by sex. Okay, in this picture down here that Miss Todd put together for you, this is showing you an example of stratified. So you first group them and notice that they're the same within. So I got all cats, bunnies, dogs, and birds. Then what do? We do an SRS within each strata. So I would number these 1 through 4 in each, use my random generator to generate 2 from each to create my overall sample. So let's illustrate this with an example from your text. A librarian wants to know the average number of pages in all the books of the library. The library has 20,000 books arranged by type, such as fiction, biography, history, etc., in shelves that hold about 50 books each. You want to select a random sample of 500 books. Explain how to select a stratified random sample of 500 books. Justify your choice of strata. Why might the librarian want to choose a stratified random sample? Okay, so here's one possible answer, and it may not be the only one. So what are my strata going to be? So they should be the same within the groups for strata. So how would they be the same? So I'm thinking, you know what, I'm going to stratify by type. And why am I going to do this? I'm stating I'm going to stratify by type because different types of books may be longer or shorter than other types. Now, why might I? This would provide a more precise estimate of the average page length than a simple random sample would. And now I'm going to describe how I'm going to do it. I just need to fix this to say simple, not sample. To select my sample, take an appropriately sized SRS of each type of book and combine the books selected from each type to form the sample. Here's what I mean by that, though, with specifically. So let's say, for example, if there are 1,000 biographies in this library, that would be 5% of the overall 20,000. So what I'm going to do is I'm going to select an SRS within the strata of biographies of 25 biographies because this would be 5% of 500. So it's going to be representative of the of the population if I do it this way. So there's 5% overall of biographies. So my simple random sample within that strata would also be 5%. I hope that's clear. All right, so let's look at cluster samples next. Cluster is often confused with stratified. What you do with clusters is you divide the population into heterogeneous groups called clusters, all right? These groups should be representative of the population though. Then you take the entire cluster for these different clusters that are chosen at random. Maybe I should say it this way. You randomly select a couple of clusters or several clusters and then take everything within that cluster. So whereas stratified is the same within, you're grouping it homogeneously, with clusters, they're different within. So in Miss Todd's picture here, she's showing you that, okay, so in my population, it's being separated into these clusters. And look at how all the clusters are kind of the same, okay? Now, the same between is what I mean, but different within each of them. So different within, the same between. And then you use your random generator to pick a few clusters. So this is choosing this one and this one here, and you take everything within that cluster to make up your sample. Let's look at this librarian example again. But I want to point out that efficiency is one of the main benefits of cluster sampling. It's often more practical to do cluster sampling because it's often based on geography as well. In the AP Classroom videos, Mr. Youngsaver talks about driving across a town, that it's not always feasible to drive from one end of the town. So by geography, if you pick a cluster like one neighborhood to everybody in that neighborhood, and then you do a different neighborhood and everybody in that neighborhood gets sampled or surveyed. Okay, so let's look at the library example now. So again, the librarian wants to know the average number of pages in all the books of the library. Recall that the library is 20,000 books, arranged by type on shelves that hold 50 books each. And you need to select a random sample of 500 books. Explain how to select a cluster sample, and it needs to be 500 books. You're going to justify your choice of clusters and why might the librarian want to choose a cluster sample. So my solution to this is, remember that clusters are more like location. So my clusters are formed by grouping books that are located near each other, making it easier to select the random sample. We need to remember choose 500 books, okay? And there are 20,000 with 50 books on each shelf. So that means there's 400 shelves. So what I'm going to do is one shelf would be a cluster. So I am going to need to pick 10 different shelves to get my 500, 50 times 10. So I'm going to assign numbers to each of my clusters. There would be 400 clusters, 400 shelves to get 20,000 books. So I will number them 1 through 400, use a random number generator to get 10 different numbers. Once I have those 10 different numbers, I'm going to take every book on the shelf. All right, so randomly select your 10 shelves and then every book in that cluster. And again, what's an improvement? It's, it's easier. It's probably quicker. You're not running all over the place. You just do one entire shelf. Another sampling method is known as a systematic sampling method. And this is like according to a rule, systematic. It's defined as a sampling method in which a sample is drawn by selecting individuals from a sampling frame according to some random starting point and a fixed periodic interval. So I use a random number generator, and let's say it produces the value, 8. And I stand at the front door in the morning and I ask the 8th student who he thinks will win the next election. And then I ask every 10th person who walks through the door after that. Okay, so random starting point and a fixed periodic interval after that. So not possible usually to ask every single person, but you stop them on a periodic time period to ask. Finally, your textbook mentions that sampling schemes that combine several different sampling methods, we call these multi-stage, okay? So a lot of times you'll see things described where it's doing, more than one sampling method. What I would like you to do now is pause the video and see if you can identify what type of sampling method is described. So we need to survey a random sample of the 300 passengers on a flight from San Francisco to Tokyo. Name the sampling method described. So first it says they pick every 10th passenger as people board the plane. That one is systematic. From the boarding list, randomly choose 5 people flying first class and 25 of the other passengers. This one is stratified, okay? Because I'm creating groups that are the same within. My strata would be the class that you're flying, first class versus economy. Part C, randomly generate 30 seat numbers and survey the passengers who sit there. This would be a simple random sample. Randomly select a seat position, the right window, the right center, the right aisle, etc., and survey all the passengers in those seats. This one is a cluster. Think of it as, more on location, and then you're sampling every person in that location. So the sampling methods we just looked at are typically good sampling methods if they're producing samples that are representative of the population. But sometimes there's poor ways to generate samples. So a sample that's generated on voluntary response. This one happens a lot. This allows people to choose to be in the sample by responding to some sort of general invitation. This always produces biased results. Remember, bias is an overestimate or an underestimate of the true feeling. Okay, or in this scenario, if we're just asking for feelings, or the true number, true value. Because people who volunteer to participate are usually more passionate about whatever you're asking. And then there's a convenience sample. Okay, this happens because it's easy to do compared to a lot of the other methods. So convenience sample selects individuals from the population who are easy to reach. Unfortunately, again, this group it may not be representative of the population. In the next video, we will look at types of bias.